This video is on the objective perform and interpret a two-mean hypothesis test where the population standard deviations are unknown. So you're going to be using the student's t distribution here with technology. Right? So this is performing a two-mean hypothesis test with your calculator. Right? And I have the TI-84 Plus Silver Edition on my computer here. If you have a TI-83 or 84, right, they're very similar. Please click on the More instruction. They'll show you exactly how to use an 83 to perform what they ask us to perform here, these two mean hypothesis tests. Alright, so again, please look at More instruction, look at their videos, their notes, their examples, how they're doing things on the TI-83. Alright. So here, an educational consulting group claims that there is a difference in the mean student loan debt of students who attend private four-year colleges and the mean student loan debt of students who attend out-of-state public four-year colleges. The accompanying table lists the student loan debt of 10 randomly selected students who attended private four-year colleges and 10 randomly selected students who attended out-of-state public four-year colleges at the time of graduating college, right? So you're given the sample data, right? You're not given the sample mean or the sample standard deviation or anything like that. Now you can find it, right? You know how to find a mean and a standard deviation, so you could do that if you want for these samples, but again, we're going to be using the calculator here, entering lists of data and then having the calculator run a test for us. So here they're saying assume the population variances of student loan debts are equal for both private colleges and public college attendees. So this is huge. If you assume the population variances are equal, that means we're in the pooled scenario, right? Where they would be calculating that SP, the pooled estimate of the standard deviation. So that'll come into play when we go to the calculator, right? Because they're going to ask you in the calculator, pooled or no? Is it a pooled scenario or not? If you're assuming the variances are equal, it is pooled, and that they're normally distributed. Okay. All right. So let the students who attend private four-year colleges be the first sample. Let the students who attend out-of-state public four-year colleges be the second. At the 5% level of significance, is there evidence of a difference in student loan debt between the two groups? And then use this. Now find the test statistic and p-value, round both to 3 decimal places. Now these things will come up on the calculator. All right. So first, before I go to the calculator, let me write some of this stuff down. All right, some of the information. Now the thing we're asked to test, the claim. All right, they're asking us to test. They're saying, is there evidence of a difference in student loan debt between the two groups? So that there's a difference, that mu1 is not equal to mu2. And again, these are the private colleges, the public college. So the average private college debt is different than the average public college debt. Then your null hypothesis would be that they are equal. Right? This would be the alternate because it doesn't involve equality. All right. And the value of alpha they gave us was 5%, and they gave us our samples. And this is where it's a little different than before. We're given all the data. We're not given the statistics. So I'm going to enter these two in my calculator. Now, hopefully you remember how to do that. Here's my TI-84. Remember how to enter lists. you hit the stat button, hit edit, and then down list L1, I'll put all the private debts, right? So 40,332, enter, and then I'm gonna stop here and I'll come back when all these are entered. So I'm going to enter down L1, I'm going to enter the private sample, the debts for the 10 private college students. And then down list L2, right, a separate list, I'm going to enter the 10 public college student debts. And I'll be back when I have all those. And I'm back, and I've entered, again, down L1, down list L1, I've entered the private student debts and the public student debts, the 10 of them, down list L2. It took a while, but I got there. Alright, now let's get out of here and run this, two mean t-test. So remember where you run tests from. Hit the stat button, go over to tests. Remember, z-test and t-test were, for hypothesis tests about one population mean. Go down to where it's number 3 and 4 here, two sample. Now, this is a case where the two population standard deviations are unknown. So our test statistic will be a t-score. We're going to be working with a t-distribution, students t with so many degrees of freedom. So go down to number 4, two sample t-test. This is for a test about the difference between two population means. Now it's going to ask you, do you have the data, which we do, or you could also do this if you're just given the statistics. If you're given the mean of sample 1, the standard deviation of sample 1, the size of sample 1, the mean of sample 2, the standard deviation of sample 2, the size of sample 2. If you're just given the statistics, go to this area. But we're not given those values, right? So we're just given the data. Alright, and then what's list 1? L1, right? I had all my data down L1. It's already L1. If it's something else, just plug in, the other list number, whatever list you have it down. List 2 is down L2, right? This is the public school debts. Is there a frequency list for list 1? Well, no. Every value in list 1 is counted one time, so I'm going to leave frequency 1 as 1. Same thing for frequency 2. Now, this next line is what does the alternative hypothesis look like? Is it a two-tailed test, a left-tailed test, or a right-tailed test? Well, we saw mu1 is not equal to mu2 was our alternative, so I'm going to leave it where it is. And here's, is it pooled? Are we in the pooled situation or the non-pooled? And I showed you earlier, right? Remember, it's still highlighted here. Assume that the population variances of student loan debts are equal for both groups. If you're assuming the population's variances or standard deviations are equal, that is a pooled scenario. So yes. If you're not assuming they're equal, then you'd go no there. And then calculate. Now look at all the stuff that comes up, right? It tells you what the alternative hypothesis looks like. It gives you the test statistic. That's something we have to enter, t-score. Gives you the p-value. Now I think I've mentioned this in a previous video too. Be careful. Remember, p-value is between 0 and 1. It's a probability value, an area under the curve. So 9.397 is not the p-value. See this thing at the end here, the e minus 6? This means times 10 to the negative 6 power. Or in other words, move the decimal place to the left 6 places. So move this to the left 6, so the p-value is 0.000000939. It's 0.5 zeros and then a 9. So it's very, very small p-value. Degrees of freedom, 18. Right. And then it gives you the sample, the private school debt students mean debt, the public school mean debt. Gives you the standard deviation of the private school kids, the standard deviation of the public school people. It gives you that SP, right, that pooled standard deviation. The size of sample 1, the size of sample 2. It gives you all this stuff. But all that we care about are the test statistic, and the most important thing is the p-value. And if you're rounding to 3 decimal places, the test statistic would round to 6.089. Right? So back here, the t, 6.089. The p-value, again, be careful. It is not 9.397. One more time, this e minus 6 at the end means move the decimal place left 6 places. So it's 0.0000939. So the first 4 decimal places would be zeros. So the p-value is 0.000, or you could, I think you could just type 0 there, because it's really, really small. All right, now let's submit these. Wonderful. All right, and again, they show you, read through the answer explanations. They're talking about how to do that on your calculator. This is what you'll see also in the more instruction. All right, and that's it. Now, I'm sure that you can do other things, and they'll ask you for the, the conclusion and whatnot. So let me go back to my paper. We found our p-value, right? The p-value was 0.0000009 something, and the p-value is definitely less than or equal to alpha, right? Alpha was 5%. So just remember what that means, right? If the p-value is less than or equal to the significance level, it means we'd be rejecting the null hypothesis. Right? I would reject the null hypothesis. So I'd reject this statement that the debts are, the average debts are equal, and we'd accept this other statement, right? And that was I believe that was the claim as well, right? This is what we were testing. And then you make your conclusion and say, oh, well, if we're rejecting this, then we're saying there is enough evidence. There is sufficient evidence or enough evidence to support the statement that private debt and public debt are different. That, average private debt, the private school student debt, I'll just say private debt and public debt are different. We'd say something like that. There is sufficient evidence to support this alternative hypothesis statement because we rejected the null hypothesis. All right, so they didn't ask about that, but they might. All right, if they ask you for a t-score and a p-value, they might ask you for, okay, now will you reject the null hypothesis or not? What would your conclusion be, regarding the initial claim? You still might be asked that stuff, so just pay attention. And hopefully watching me do this and looking at more instruction and reading the answer explanations, hopefully all this stuff helps you when you're working on this stuff on your own. And thanks for watching.